Yesterday we have done a similar question just like this. The only difference is that only in this question this is aluminum rod. In that question that was a steel rod. Now let me read this question. An aluminum alloy plate of 400 mm into 400 mm into 4 mm thickness size at 200 degrees Celsius is suddenly congealed into liquid oxygen at minus 183 degrees Celsius. Starting from fundamental or deriving the necessary expression, determine the time required for the plate to reach a temperature of minus 70 degrees Celsius, assuming H is equal to 20,000 kilojoule per meter square per hour degrees Celsius, and Cp is equal to 0.8 kilojoule per kilogram degree Celsius, and rho is equal to 3000 kilogram per meter square. And these are all the given data. H 2000 kilojoule per meter square hour degree Celsius, Cp 0.8 and density 3000. This is the equation to solve this type of question. Let me explain all the parameters in this equation. T is the temperature, Ta is the atmospheric temperature or the exposed temperature, Ta is the initial temperature, and e raised to minus h is convective heat transfer coefficient, As is surface area, rho is density, V is volume, and C is specific heat at a constant pressure. And this equation can be used only if the value of Biot number is less than 0.1. So first we need to calculate the value of Biot number, and the equation for Biot number is HLC by K. H is the convective heat transfer coefficient, LC is the characteristic length, K is the coefficient of thermal conductivity. H is given 20,000. LC can be calculated by volume by area. Volume we have calculated 0.00064 divided by 0.32, which is equal to 0.002 meter. We know the conductivity of aluminum as 240 watt per meter square, watt per meter degree Celsius, which is can be here we know that H is given in the unit kilojoule per meter square hour degree Celsius, so we have to convert it into like that in hour, kilojoule per hour. So value of K become as 770.5 kilojoule per meter hour degree Celsius. Here in the question it is said that the time taken to reach the temperature of minus 70 degrees Celsius. So T is minus 70, and in the question it is said that exposed to oil quenching, and the exposed temperature is minus 183 divided by initial temperature is also given 200, minus 183 is equal to e raised to h. H is given as 20,000 into area. Surface area we can find out is a square plate, so it is 400 mm, 0.4 into 0.4 into on both sides it is 2 into 0.4 into 0.4, that is 0.32 meter square. Volume base area into height, area we know 0.4 into 0.4 into thickness it is given 4 mm, that will be 4 into 10 to minus 3 meter. Therefore the volume is 0.0064 meter cube. And by substituting the equation, e raised to minus 20,000 into 0.32 divided by 3,000 into 0.0064 into Cp it is given as 0.8 into tau. And now minus 70 minus of minus 183 divided by 200 minus of minus 183 is 0.295, which is equal to e raised to, and by solving all that we get a minus 4166.67 tau, which is equal to 1 by e raised to 4166.67 tau, that going left side, and which is equal to 1 by 0.295, and we get 4166.67 tau is equal to ln 3.389. By taking log we get this, and we get the value of tau as 1.054 second. Here we have to multiply it with 3600, so because that in H and all their unit is kilojoule per hour. To convert that into second, we know that the SI unit is kilowatt and all. To convert that into second we are multiplying this 3600, so we get 1.054 second.